Hello, today we will see how to integrate the millimeter wave sensor LD2411s, which is quite the popular and also cheap sensor, into Home Assistant using, obviously, an ESP32 microcontroller. Here we have a very handy development board and a custom-made but very simple PCB, of which you will be able to find the Gerber files in the description. We need to take a bit of a longer route. We need to develop a platform I/O project, and we will need to communicate to Home Assistant directly, bypassing completely ESPhome. In the past, we could have used simply ESPhome because in the YAML configuration we could listen to the serial communication. Unfortunately, this is no longer possible since starting this year we cannot listen to serial communication straight from the YAML configuration. So this architecture is out of the window. I decided to switch to a straight platform I/O project using MQTT for communication to Home Assistant. So we have a straight project with platform I/O, which listens to the serial communication and manages the PWM for controlling the MOSFET, which controls the LED strip. The platform I/O also communicates with Home Assistant via MQTT. MQTT is a communication protocol, let's say, and with it we can send, let's say, messages from the development board to Home Assistant, and also the other way around. The platform I/O will publish the motion detected state, and Home Assistant will send a couple of commands. We'll send an auto manual toggle, so we will be able to toggle from Home Assistant to different mode of operation, and also turn on, turn off the LED strip when we are in manual mode. Otherwise, this command will be ignored. Since I hate soldering, I've developed this simple board. For the power stage, I use the LM2575 5 volt, which takes the 12 volts coming in from a transformer and power both the ESP32 board as well as the millimeter wave sensor. Here you can see how I power the LED strip, which we will connect also to connector J3. We will send a PWM signal to pin 1 of a logic level MOSFET, the IRL Z45N. We will be able to directly control it from the 3.3 volts of the GPIO32. So here is the PCB. It's a very simple PCB. And here is the populated board. Here is the power section where we provide from the 12 volts, the 5 volts needed for the ESP32 and the millimeter wave sensor. Here is the logic level MOSFET. ESP32 goes here, and the millimeter wave sensor with this connector goes here. Now we just need to connect ground 12 volts and the LED strip in these two connectors, and we will be done. I split this project into two sub-projects. The first one is this one, ESP Custom Libraries. Here I have developed two simple libraries for managing the MQTT communication and also the millimeter wave sensor. Here we can see the functions into details. So publish motion will take these variables and if we are connected to a client, you will publish to the specified topic a simple on or off value. We will be able to show this into Home Assistant as well as to treat it as a simple binary sensor. The callback will manage the messages that are coming in from Home Assistant. This is hard-coded, which is not ideal, but for now the two toggles on Home Assistant are mapped here. So here we will be able to toggle between manual and auto mode, and here we will be able to set the LEDs on or off from Home Assistant. Regarding the millimeter wave libraries, the only function that we're gonna need is this one. Here you can see there is a weird class. We will talk about this later, but basically this will listen to the communication coming from the millimeter wave sensor, and it will interact with this instance of the variable of class millimeter wave in the other project. Basically, we will just listen to this message. The sensor in its default state sends this message, which denotes the type of motion detected. So we have 00 no target, 01 static target, and 02 macro motion detected. If we are receiving a 01 or a 02, we will also get the distance. So we will listen to this message and analyze it. We'll start waiting for a double AA message. Once we have found that, we can store all the other bytes up until the end of the frame, and we know that the third byte, the byte 2, denotes the presence of motion or absence. If we are reading 02 or 01, we are detecting motion, 02 is macro motion, 01 is motion, and if we are reading 0, we know that we are not detecting motion. We will store this, all this information in this variable that we will see briefly. Here is the main project. We will interact with the LED strip via a MOSFET. We will drive it via a PWM channel. These are the settings for it. We will control the pin 32, GPIO 32. Here we will set up our wireless network. And here is the millimeter wave instance, which I have defined like so. This is the structure that we are gonna pass to the other project that we saw a second ago. So we have a buffer in which we will store the content of the frame, and the most important variable is the presence detected variable. In the loop, we will listen to messages coming from Home Assistant, and we will behave differently whether we are in manual or automatic mode. If we are in automatic mode, if we detect motion, we will turn on the LEDs. If we stop detecting motion, we will turn them off. We will also publish the motion to the right quote-unquote mailbox on Home Assistant, so it will know whether we are detecting motion or not. If we are in manual mode, we will listen to a command and we will turn on or turn off the LEDs accordingly. Regarding Home Assistant implementation, we will need to set up the MQTT. We will need to add 3 devices. The first one is the motion state. So it is an information that will be sent from the device to the Home Assistant. we can see that publish motion needs a topic. This is the topic that the device will send. We can find this here. And the payload that will be sent will be on or off depending on the state of this variable. If we see in the function itself, we can see that we are publishing here on or off depending on the state of motion to the topic gym/LD2411_motion. Regarding the other way around, so when Home Assistant needs to communicate to the device, we will need to subscribe here to the topics. We need to listen to the state of two binary variables. The first one is the sensor mode, auto or manual. So we will listen to this message. We can go here and we can see that this is the switch that we have created in Home Assistant, and this is the topic. In this way, we will be able to toggle between automatic or manual mode. For controlling the state of the LEDs when we are in manual mode, we use this topic that we also have created here. If you go in info, we can see that the topic matches, and we send as a payload on or off depending on the state that we have selected. So toggling between on and off, I will be able to turn on and turn off the LEDs when we are in manual mode. Of course, now I can use this information, the motion information, in any other automation that I have running on Home Assistant, effectively having integrated the millimeter wave sensor into Home Assistant without using ESPhome. So I have connected 12 volts, ground 12 volts, and the LED strip to connector J3, and also I've connected the USB Type-C cable to the laptop in order to see the serial communication. Now let me turn on the 12 volts line. Now we are in automatic mode. Now if we go to Home Assistant and we go to Device Services and QTT, we can see the three devices that I have set up. So first of all, we will switch from automatic to manual mode. Oh no, now we are in automatic mode, now we are in manual mode. Now that we are in manual mode, we can control manually the LED. Turn on and turn off. Turn on and turn off. We can also see the motion state. Now there is motion detection because the sensor is here, so we are clearly detecting movement. There you have it, a simple way to detect motion using LD2411s and communicate the result to Home Assistant. This board can also control an LED strip via the dedicated MOSFET, but obviously you can integrate the information about presence or lack thereof into whatever automation you have running into your Home Assistant. You will find in the description the link for downloading the fabrication files, and as well as the tool repository, which I wrote for developing this simple project. I hope you'll find this useful, and see you next time.